Yes, you are welcome to the physics class again. Today is physics day 6. Physics day 6. And physics day 5, we had a look at the young modulus. Young modulus. And I told you with that idea, we could give the Hooke's law the other way around by saying that according to Hooke's law, provided the elastic limit of elastic material is not exceeded, that the stress of that elastic material is proportional to the strain. I explained to you the stress. Stress simply means force over area having the units of Newton per meter squared, and then strain is increase in length pay the original length, which I say is dimensionless because the unit of extension is meter, and that of length, the original length is meter. So if you cancel out, it's dimensionless. Today we will look at the work done. The work done in stretching an elastic material or in compressing it. In compressing it and also the elastic potential energy of this elastic material is elastic potential energy. Potential energy is the energy due to the state of that object or its position. So this object, like this as it is, has its potential energy. Has its potential energy. It is this energy it has that helps us to do what? To stretch it or compress it. So the work done in stretching this, the work is done in stretching this elastic material. The work is also done in compressing it. Why? Because this spring has a stored energy, what we call potential energy, elastic potential energy. This force is what helps to compress or to stretch it. Okay, now this work done is measured in joules. The work done is measured in joules. Joules. The potential energy is also measured in joules. It is that potential energy it possesses that helps us to do work of stretching or compression. Okay, what we want to do now is this. We want to find, assuming that this is the original length of this elastic material. Now I stretch it now. This is original length. I stretch it now. I stretch it. Then it increase. From here to here now is the increase in length. That is the extension. Okay, the force here, let's assume here, before the force here, the original force here, F0 here. Now here is the final force applied here, F1. If you are to find the work done in stretching this, the work done is going to be the average of this force, F0, F1, multiplied by E. E. So the work done in stretching this is equals to F0 plus F1 all over 2 multiplied by the increase in length extension. This F0 is 0 before that's the initial force, the beginning of the force. So it is 0. So we have 0 plus F, which is this F1 now, multiplied by E all over 2. So the energy stored or the work done in stretching this elastic material is equals to F over 2 times by E. That is F over 2 by E. This work done is equals to the energy stored in the elastic material. But I told you that this F, by Hooke's law, F is equals to KE in our first class, physics 001. So if you remove this F now and substitute with KE, we have that the energy stored or the work done is equals to K, this K, E times this E, all over 2. So we have work done now is equals to K E squared all over 2. So that is what you can use to calculate the energy stored by a string. If you know its force constant and you know the increase in length, you can get the energy stored in elastic material. If you know the force applied and know the increase in length, we can also calculate the energy stored or elastic potential energy of that elastic material. Turn your notification bell so that anytime we upload new video, you'll be the first to see it and enjoy it fresh. Thanks.